Okay, so applications for expected values. We're going to look at different ways we can apply expected value to situations and use it to help us decide, make decisions. So for gaming, there's a card game at the fair. You want to decide if you want to play. The game costs $3 for drawing one card. You can win $10 for a face card. You can win $50 if you get an ace of spades. Everything else, you win nothing. So what is the expected value for the game? Well, there's two ways of doing most of these situations, especially when you have to pay to play. Okay, so our first situation, we're going to be talking about just the winning amount. So you have the probability of what you're getting, and you need the value of what you're getting. As we talked last week, probability and value is what you're going to multiply together to get your expected value. So for face cards, we have three different types of face cards, Jack, King, or Queen, and there are four different suits. You have your hearts, your diamonds, your spade, and your club. So four different suits, three different cards, so that's 12 total cards. So we have 12 out of 52 for a probability of getting a face card, and we can win $10. The second set here is the ace of spades. So we're just going to write ace there. So since there's only one ace of spade in the thing, that would be a 1 out of 52 for the deck for probability. But we can win $50, so there's our value. And then the last one is the rest of the cards. So for the rest of the cards, well, to figure that out, there's 52 total cards. You have to subtract the 12 that you had for the face cards and the one ace of spade. So that leaves you 39 possible cards. So you have a probability of 39 out of 52 to get anything for the rest of the cards. And in this case, you're not going to win anything. So that would be a 0. So multiplying these together, you take your probability, multiply it by the value, and add that to the next probability, multiplied to the value, and the last probability multiplied to the value. Okay, so when we multiply this together, the expected value of winnings for this game is $3.27. Now, this does not take into account the pay to play. So, since we have to pay, what you have to do is you take your expected value and you subtract what you had to pay. So in this case, $3.27 minus the $3 you had to pay anyway, because that would be your expenses, and that's going to give you a net profit of $27, or not $27, sorry, 27 cents. So that would be the expected winnings for that game. Now, the second way of doing this, we did winnings, and this is where you had $10 winnings, $50 winnings, and no winnings, and then you had to subtract how much you paid. The second way of doing a problem like this that has a pay to play is net profit. Net profit means that you go ahead and you take away the $3 and you figure out how much you would win, actually win, because you're just replacing the $3 you already paid, and then you get more than that amount. So the probabilities would be the exact same for these. So for the face cards, you'd still have 12 out of 52. But the value here is going to be different. So the value is going to be the winnings minus the expense. So for each value, you're going to take what you would win, but you're going to have to subtract the expense. So for this case, 10 minus 3 would be a 7. And then for the next one, for your ace of spades, you're still going to have 1 out of 52 for the probability. And since you would normally win 50, we had to pay 3, so 50 minus 3 is 47. And then for the rest of the cards, you still have 39 out of 52 probability. And since you aren't winning anything, you would just lose the $3. So losing, remember, is a negative number. So you're losing $3. So that's a -3. Now, if we multiply all this together, that gives us the 0.27 and change that we would expect to win from the game. So that would be how much you would win. So would it be something you would want to do? Well, it does have a positive value. You are earning more than what you would lose. That's your expected value. So this would probably be a game you would want to try. Okay, testing. Now, testing, we're taking a quiz in history. You've studied, so you're 70% confident of getting the correct answer. Okay, so there's a probability right there. 75% chance of getting the right answer. Okay, now if you get the answer correct, you earn 10 points. So here is our value for our probability of being correct. So we have the probability of being correct is 0.75, and we earn 10 points for each question that we get correct. Now this one sounds a little different. It says if you get an answer wrong, you only lose 5 points. So if we're only losing half of it, I guess they're giving you partial credit for trying, you lose 5 points. So in this case, we are going to take 0.25 and we're going to multiply that by -5 because we're losing 5 points on the amount. Now it says the last one you leave blank and you lose no points. So that really has no bearing whatsoever because we already have a full percentage here. So if we multiply this together and get our expected value, you could expect 6.25 points per question. Now, what if, since this is a 10-question quiz, what would be your expected score on the quiz? Well, if you take the 6.25 per each question, and you multiply that by the number of questions, which would be 10, then you could expect to get a 62.5 on this test. Now, obviously, the decimal is probably not going to be part of that, but this is an expected value. So my suggestion, study a little bit harder and get maybe 80-85% chance of getting it correct. Okay. Question number 3. It says, in many airports, a person can pay $1 for a $100,000 life insurance policy covering the duration of the flight. In other words, the insurance company pays $100,000 if the insured person dies from the plane crashing. Okay, otherwise they just get the $1. Now, there's a probability of 0.45 deaths per 1 million passengers for this airline. So how much can the company expect to gain on a single policy? So in this case, we do need to look at the net because we're talking about the company. So the company is going to lose $99,999 if the person dies. So that is a value of -$99,999. Okay, so that's our negative value. They're going to lose this much. And that is for 0.45 out of 1 million. One more zero there. Okay, so that's our probability. Now, for the rest of this probability, they earn $1. Okay, that's how much they're going to earn is $1 because they gain $1. Now, the probability for this would be the rest of this. So to get a value of 1 over 1 value from the ratio, you would need 999,999.55 out of 1 million. So that would give us a total amount of our probability. Because remember, this is the probability of not losing, not dying. This is the probability of dying. So they have to add to 1. So 1 minus 0.45 over 1 million has to equal the other probability. So if you do this in your calculator, you end up with I think my numbers are off. 1, 2, 3. Nope, I got it. Okay, so you end up with a 0.955 is what they expect to gain for each individual. So that's 95 cents, 96 cents for each one of these policies. We'll round it off to the pennies. Okay, so that's how much they expect to gain. Now, if they sell 100,000 policies, we just need to take that amount that they expected to get for one policy and multiply that by 100,000. So 0.96 times 100,000. So they can expect to earn $96,000 approximately. Now, this would be more accurate if you left it at 95.5 before you did the multiplying. That would be the more accurate number. But $96,000 they expect to earn if they could sell 100,000 policies. Okay. A construction company wants to submit a bid for remodeling a school. The research and planning need to make the bid will cost $4,000. Okay. If the bid's accepted, they will make $26,000, but they only have a 35% chance of being accepted. So to figure out the expected value, you are going to earn $22,000. Now remember, you had to pay $4,000, so this is going to be the net profit on this. We're doing net profit type. So this is 0.35. But you would lose $4,000, so that's a negative $4,000, and you have a 65% chance of not getting the bid. So again, doing your calculations, your value that you could earn, your net profit value would be $5,100. So would it make sense to actually do the bid? Well, considering you already figured out that you could lose $4,000 by not getting it, but you have a very large expected value, this would be a good thing to do. Spend this small amount of money for getting $22,000 in profit. Okay, a school is holding a raffle. There are 500 tickets sold at $1 per ticket. The three prizes are $100, $50, and $10. What is the expected value of your gain if you buy a ticket? Okay, so this is kind of almost like a dependent probability also, because of the 500 tickets, one of them will give you $100. The second one would be out of 499 tickets because you've already drawn one. So you have a $100 value that you can get 1 out of 500 chances. Okay, then there is a $50 value that is 1 out of 499 chances, because you've already got one ticket that won the first prize. And then you can win $10, and that's 1 out of 498 tickets. Now remember, if we're doing total gain, total winnings, then we have 0 out of, see, we took 3 tickets away, so that would be 400 You know what? These should be out of 500. Because there's one ticket out of the 500 that's going to win second place, and there's one ticket out of the 500 that's going to win third place. So these are all out of 500. My apologies on that. So, but there's 497 tickets left out of the 500 that will give you nothing. Now remember, this is winnings. So for this, at the end, we're going to have to subtract out how much we paid. So if we do this probability, we get a 0.32. Now that would be the gross winnings, okay? So we have to take that 0.32 and we have to subtract our $1 that we paid. So that would give us negative 68 cents that we would expect on this one. So is this a good raffle? Not for most people. Now, if it's to raise money, most people would probably do it anyway. But if you're actually expecting to win, this is a very bad thing to do because you get a negative 0.68. Now remember, the second way you can do something like this when you're talking gaming like this is go ahead and subtract the dollar. So you would have $99 times the 1 over 500 plus $49 times the 1 over 500 plus $9 times 1 out of 500. And then for this, you would talk about losing the $1 since you aren't winning anything, but you lost your money. So that would be out of the 497,500. And if you do that probability, you should end up with the negative 0.68 for your actual value when you're doing the value, since it's already taking into account that you're losing the money. So again, there's two different ways. There's the winning, and then there's the net profit that we talked about. Most of the ones we did before, we worked net profit. It's just a little easier to do because it's all at once. Okay, and that is your applications for expected values.